All right, welcome everybody to a very special combined meeting. We've got the Vertical Flight Society uh, uh, Commercial Air Transport Group, and we're teaming up with Danielle McLean and her team's fantastic organization, the HYSKY Society. And today we're going to be talking about supplemental type certificates, which is an excellent way for new technologies to be tested and added to existing aircraft and sort of pre-certified design platforms. So I'm excited to talk about that today. Danielle, real quick, love to hear about your organization and what we're going to talk about today.
Yeah, thanks so much, Andy. And if you're joining the webinar, please kindly mute your microphone. I heard a couple hot mics, but I'm Danielle McLean. I'm the founder and CEO of HYSKY Society. We're an educational nonprofit charity dedicated to decarbonizing aviation with hydrogen. And what led to this special joint webinar with the Vertical Flight Society's Commercial Air Transport Group was our hydrogen certification aircraft our hydrogen aircraft certification course. And we had so many questions on STCs or supplemental type certifications that we decided it was necessary to do a joint webinar on it. So we're so excited to welcome three amazing speakers today: Mike Hirschberg, David Weber, and Ken Swartz. And I will stop there and kick off with Mike Hirschberg. Mike, the stage is all yours.
Great. Thanks so much, Danielle. And thanks, Andy, for co-hosting this and Al and all the volunteers that do this work to help educate people, raise a level of understanding. And I hope that this webinar will be very valuable for you. And I got to go share. All right. You should see my slides.
Looks good.
All right, great. So let me just adjust my screen here for a minute. All right. So yeah, as Daniel mentioned, I'm Mike Hirschberg, and I'm very pleased to help moderate this session. As probably most of you guys know, and my slides won't advance. What is going on? What is going on? Try that again. I know we tried this before.
Yeah, you were able to advance on the tryout. It's okay.
Stand by.
I think Zoom invented technology to change the sharing protocol every 5 minutes.
Yeah.
There we go.
Looks good, Mike.
So, as most of you guys know, I'm director of the Vertical Flight Society from 2011 to 2023, and recently became a consultant. My consultancy is Hirschberg Heuristics Advisors, also H2. Best way to get in touch with me is on LinkedIn. If you don't have my email address or cell, I get a lot of emails, texts, everything else. I was very pleased to go on a visit through the Canadian Advanced Air Mobility Consortium to see United Therapeutics Bioelectronics in up north of Montreal, and visit their work on their hydrogen helicopter demonstrator. And they're using the Robinson R44 as an experimental test platform. But the idea is that they would work with Robinson and have an STC or modification to be able to produce hydrogen-powered, actually R66s. So the R66 uses a turbine engine, the R44 uses a Lycoming piston engine. But the idea would be to probably through an STC is to put those into production and have an emissions-free helicopter. Now, this is the experimental version, so it's got stuff that's scabbed on it. So this is not a production configuration, of course, but you can see it's the basic airframe. So an STC is taking a basic airframe that already exists, whether it's a helicopter, a small airplane, large airplane, and making some modification to it. There's the piston engine. So, if you replace that, Robinson's also looking at just electric powered, battery electric. So you would replace the piston engine with an electric motor and then either power that through batteries or through a hydrogen fuel cell system. And the rest of the airplane, you don't have to certify the entire aircraft. I'm going to have a few didactic slides here. So part 21 is the basics for certifying aircrafts and the basic procedures. And then part 23 and 25 are for fixed wing, horizontal takeoff and landing aircraft. 27 and 29 are for they call rotorcraft, but they're really just helicopters, or the only rotorcraft that are being certified that way. Then there's other parts for balloons, and importantly for aircraft engines and propellers. This is a slide I got from Dave Weber. Actually, a lot of these slides are from Dave, who will be speaking after this. He's also got the same slide. But the important things I want to let people know is Part 21 explains how to certify airplanes. Or aircraft. It's the basics, right? And so there's divided into types of aircraft. So Part 21, paragraph 17A says if there's already a certification framework, part 23, 25, etc., then use that. If there's not already a path, you come up with a new airplane, whether it's a flying saucer or a tilt rotor or a powered lift eVTOL, you've got to use the 2117B, which is a special category, special class. Dave talks a little bit more about a class. So there's an airplane as a class, a rotorcraft as a class, and then there's categories of normal, which is smaller, and then transport, which is the larger ones. And again, as I mentioned, there's the part 33 is engines, and it says engines. So even though technically electric motors are not engines, for the purposes of the FAA, you got to fit your round hole in a square peg. So you just call electric motor an engine, so it can be used for part 33. But basically, whether you go with the 2117A, the established path, or 2117B, which means you're working with the FAA to design the certification pathway, you end up with a regulatory certification basis. So your aircraft is certified when all these components, when the parts are satisfied. So again, part 21 is the basic procedures. 21A is the general. Subpart B talks about type certificates. C is actually about temporary TCs, which I'm not familiar with those. D is changes. So changes for the OEM, the original equipment manufacturer, the aircraft developer can amend or update their type certificate, and then third parties or people who want to, companies, manufacturers who want to update an aircraft that's already fielded and modify that's through an STC. And these are all links. I put the PDF in the chat, so you can get my slides and actually click on these links. Then there are advisory circulars explaining how to get a supplemental type certificate, and then FAA orders. And here's the link at the bottom for getting all the information. So again, and there's maybe some more experts on the line here that'll be able to add more personal reflections on here. But basically an amended type certificate, and even if they call it supplemental type certificates STCs, they don't really call amended type certificates ATCs, because ATC is in FAA speak for air traffic controller or air traffic control. But just really to incorporate a major design, an amended type certificate is to to do a major design change, and I believe it's usually used directly into the aircraft design as part of the production line. So this is something like, you've got your Boeing 737, and then you want to develop a 737-800 as a variant. So they're going to be producing these things, so they get an amended type certificate. for that. And the benefit of having an amended type certificate, if you're putting bigger wings on it, but it's the same fuselage, you don't need to redo all the testing for all the parts of the fuselage. If you're putting new engines on it, and it's a new design, you don't need to test the rest of the aircraft, but you do need to make sure that those engines or those wings, work in all possible situations. There is a difference between a major and a minor change, and basically a minor change is one that has really no effect on the weight, the balance, structural strength, reliability, operational characteristics, or other characteristics that would affect the airworthiness of the product. So if you want to change your, I don't know, and I'm not an expert in this area, so I'm not going to give good examples, but if you want to change your the overhead bins, or maybe change the Wi-Fi, the entertainment system in the aircraft, and it doesn't affect anything exterior or things like that, then you're just making sure that that system doesn't have any interference effects and things like that. So that might be a minor change, and then anything else that affects one of these things is a major change. Yeah, so here's a minor change. So this is, you work out a process for the FAA to get that approval. A major change, you need to do all this substantiation work and testing, and that can be a pretty extensive, a lot of testing, a lot of proving that it's not going to affect the safety of the aircraft. So this is the paragraph that talks about the supplemental type certificate. So if you are not if you don't hold the TC, if you're not the manufacturer for this product and you want to add something to the aircraft, you need to use an STC. If you are the OEM, if you are the manufacturer and you have the TC, you may still want to do an STC if it's something that's a major change, and like I said, I think it's for a system that's already been fielded. And these are the application, these are the paragraphs. Again, you can click on these from the PDF I put in the chat. So now we're going to turn over to Dave Weber from the FAA, and he's going to give some of his insights into supplemental type certificates. So I'm going to stop sharing, and then Dave.
All right. And still sharing, I think, is not letting me in.
Still sharing, huh?
And also, Dave, please give a brief intro about yourself. Tell us who you are.
Here it is.
Okay, I'll do that. Let me go ahead and share here. All right, let's see if we get this to work.
Yes.
How's that? Okay, great. Yeah, thank you, Mike. Yeah, I'm David Weber. I'm a flight test engineer. Been with the FAA since 2006. I'm up here in Seattle. Despite that phone number there, I picked up that phone number when I was working out in Kansas City and doing a lot of the new and novel emerging concept stuff, eVTOLs, small airplanes, and that type of thing. But I'm back in Seattle now. Spent half my career in research with NASA before I came over to certification. So I've been living in a part of the FAA where we're doing a lot of emerging concepts. So I know a lot of the people on here. And I'm a flight test guy, so I won't pretend to be an expert with all the legalities of certification, but I have had to delve into them quite a bit. So I know a little bit from the perspective of STCs, that I know some of the pitfalls that you can run into as we go through certification. So I hope I can help to shed some light on this subject for this audience. And I just need to hide this ribbon. I don't know, it's blocking me. Okay, there we go. So this is a slide I've shown quite a bit, when I talk about birds of a feather flocking together, shared flying qualities, characteristics, and performance. I need to advance here. I show this quite often because when it comes to the efficiency of the national airspace system, it's important that we set minimum standards appropriately, and then the aircraft that fly to those minimum standards are able to work and play well together in the airspace. So it's kind of important because to me it's the principles that are behind what we call vehicles categories and classes. It's really useful for us with the national airspace system to be able to uh, group different types of aircraft so that they can operate from the same types of infrastructure. The airman training can be somewhat uniform, pick up the important principles, and that helps us with not just having the safest but the most efficient aviation system in the world. And I believe as I study Part 21 and been working in it, that's the intent of our certification requirements. So we're talking about STCs today, and as Mike mentioned, the supplemental type certificates are really important facilitator for introducing new technology in the NAS when you can modify an existing airframe and then introduce new technology into the NAS. It's important to follow the STC process. So I'm in the aircraft certification service, AIR. I actually sit in compliance and airworthiness more than you want to know about the FAA organization, but I'm in Air 700. But I support policy and innovation, our Air 600 division, and basically we're working from these new and novel concepts. The technology gets integrated, and when you integrate with an STC, you're integrating technology into an existing airframe, and we go through the compliance and airworthiness process to certify your aircraft, and we give a design approval, and ultimately that gets technology into the NAS, and a supplemental type certificate you might add different models to that supplemental type certificate over time, and that's what we're here to talk about today. And that's all done through the aircraft certification branches, and I'm involved in between I'm part of the certification branch. I certify aircraft, but I also work with the standards branches to figure out the appropriate standards for these new and novel designs. 8110.4, Mike mentioned this. This is the type certification process. The type certification process is the same whether you're a TC, an amended TC, or a supplemental type certificate. And basically, the idea is to move from left to right, get your conceptual design, your cert plan. In flight tests, we're very interested in early familiarization briefings, so we can gain an understanding of the overall design. And quite often, it's a parent aircraft and STC is what it looks like on paper, but quite often there's a whole bunch of other things that are added together that allow us to really understand your design. So we do need to understand the concept of the operations, particularly if they're changing significantly from the parent aircraft. You move into requirements definition. Like I said, looks like a left to right. Establish that certification basis, come up with airworthiness criteria. If we're using so-called performance-based requirements, which is something that's happens in Part 23 and in special class right now, establishing that certification basis is sometimes requires some clear understanding of the issues and some understanding of the means of compliance and equivalent safety findings that underline the airworthiness requirements that you're going to be designing to. We come to agreement on that, and that's an iterative process, and then you can move into compliance planning and implementation. And you can see there's a type inspection authorizations and flight tests. That's a big part of my job. So we're very interested in getting into compliance planning and implementation. And ultimately, what we find is that this is an iterative loop. As you get into flight tests, you may learn more about your new and novel design. You'll discover where some of the Achilles heels are, you may have to go back and redesign a bit. And sometimes we need to modify even the requirements definition, either through modifying the means of compliance, making equivalent safety findings, or in some cases, even updating the certification basis. But if all goes well, downstream, we get to an STC issuance. Quite often that STC issuance might be for one aircraft to start with, one model, but you may be able to add models over time with your STC. In the end, the common output is Mike showed the slide of the certification basis. The certification basis, you have an ingoing certification basis, and once you've met all the requirements of the certification basis and you certify your vehicle, you'll have a type certificate data sheet, and that captures that regulatory cert basis. It captures what you actually certified to after this iterative process that is type certification. This TCDS is part of the type design. It's legally enforceable, and it basically looks at where the different areas that have been looked at. So with an STC, in flight test, I'm typically only interested in the major modifications because quite normally when you do a major mod, it's going to affect your performance and flight characteristics. It's probably going to affect your operating limitations and ops manuals, and these subpart B and G areas are where flight test lives. So that's why I'm here to talk today. And we also support all the flight tests for loads, flight envelope, design and construction, power plant, and what have you. And that's it for me. Mike, I'm back to you.
And real quick, can we have everybody mute if you're not a speaker? Getting a little bit of background noise.
And also, I think Tom can mute them.
Thank you.
Yep. All right. Thanks so much, and we'll have plenty of time, hopefully, for discussion. Ken is going to present some of his experiences and insights now.
And Ken,
Okay.
please give us a bit about your background as well. And just real quick, I wanted to announce to the people that are joining on HYSKY Connect, you can join via Zoom, and I put the link in the chat if you want to participate in the discussion. Okay, over to you, Ken.
All right, just give me a sec here. I'm just trying to access the the share the screen view because the other thing is going over top. There we go. Continue to share. Okay, can you see my full slides?
Yes, perfect.
Okay, so I'm Ken Swartz of Aeromedia Consultants. I've been in the aerospace and commercial aviation industry most of my career, and in parallel have been writing on the industry, particularly rotorcraft, helicopter industry, and regional airlines. I was a market analyst at Bombardier on the CRJ and Dash 8 programs, and I've had a number of consulting assignments with companies like Pratt & Whitney, CAE, and a number of operators. Okay, so I'm going to look at in-service examples. If you're out in the field, what do you see today, and how does that provide a sort of foundation for what we're going to see in the future? When we talk about the STC process, and just to sort of build on what was said previously, this is a Transport Canada example. We have a number of phases to the process, which require in each stage a dialogue with the regulatory agency, ultimately culminating in a STC. But then there's post-certification activities because the STC holder is also responsible for technical support of those aircraft, and in many cases is selling the STC upgrade to operators, or in some cases back to the original OEM for incorporation into an aircraft. And in parallel with the actual physical work on the aircraft is a whole set of documentations to show the changes that have been made, both for secondary owners of the aircraft, but also the regulator also has to know what's going on. When we talk about STCs, it was touched on briefly earlier, there's major and minor. I would say that as Dave covered, major would require a flight test program. Minor, if we look at the helicopter industry, could be new cargo hooks, winch installations, emergency float systems, air conditioning, heaters, bubble windows, cargo baskets. These are all minor things that we will also expect to see in new electric aircraft as they enter the field and operators require additional upgrades that weren't provided with the original aircraft. Common example is an air ambulance interior on a helicopter. Airbus delivers a helicopter new to a completion center, and all those items that you see in the aircraft, the medical equipment, the mounts, etc., are all STC'd in items. The same thing would apply to, say, an eVTOL or an eCTOL that was being customized for air medical. Anyways, typical aircraft manufacturer, engine manufacturer strategy is one to get their aircraft onto a new clean sheet design. In some cases, engine development precedes aircraft development. At least that's how it was in the turbine era, where you work with the advanced design team to come up with a new aircraft concept. And then the other thing that occurs is knocking an older engine off the wing of an existing aircraft. And that can be both at the OEM level and in the retrofit market. A good example at the OEM level is the incremental evolution of the King Air, the Beech King Air and the Pratt & Whitney PT6. Over the last almost 60 years, there's incremental engine upgrades and aircraft upgrades. But similarly, these engines are also being retrofitted on existing aircraft designs that may be separate from working with the original OEM. If we look at turbine engine retrofits, and many of us have been out at the airport and seen these aircraft over the years, Convair 580. Convair 580 was an upgrade of a radial engine Convair from the 50s. Fleet is disappearing, but there's still some in cargo and fire attack operations. Rolls-Royce Dart was also retrofitted. In the airline industry, CFM56 turbofan replaced turbojet engines on the commercial Douglas DC-8 and also on military aircraft like the KC-135. In the turboprop world, we have Pratt & Whitney engines found on numerous agricultural aircraft that started out as radial engine aircraft, and similarly Garrett, which is now Honeywell engines on ag aircraft. In the fixed wing world, often the engine is flight tested first before it goes on to a new aircraft. Here's a Pratt & Whitney aircraft at Oshkosh, which is extensive STCs in order to attach other engines to the aircraft. So it's not a conversion as such, but the STCs were required to fit different kinds of engines either under the wing or to the fuselage for flight testing. Here's a Convair 580, again, Allison Rolls-Royce engines replacing a piston engine, radial engines. DC-8s is in its twilight. There's only a couple still in service. This is one with a CFM56 engine replacing the old JT3Ds. Ag aircraft, piston to turbine. Basler remanufactures DC-3s with turbines. This one is used every year in Antarctica on skis. Here's an example of a de Havilland Beaver that has both a completely new wing and a PT6 engine. It's done as a conversion, and it's also been STC with a float system. Here is a de Havilland Otter where the radial engine was replaced with an Orenda inline engine. The engine program went bankrupt. It was acquired by a company in the States, and this aircraft eventually, because of the lack of technical support, was converted to turbine. Turbo Otter, very popular, particularly on the Northwest coast, sightseeing flights, commuter flights, British Columbia, Seattle, Alaska. A lot of cruise ship passengers will fly over the glaciers in this kind of conversion. When it comes to the helicopter industry, similarly, there's been conversions of existing aircraft to new power plants, sometimes initiated by the OEM, sometimes initiated by the engine manufacturer, and sometimes initiated by the operator. As an aircraft goes through an evolution, part of the technical aspect is the data plate. Here's an Airbus A-Star or a Curie with 3 different data plates, built in Marignane by Aerospatiale, upgraded from a B to a BA by Eurocopter, and similarly to a B2. Here's an example of an OEM that has been open to the upgrade of their aircraft, and both through and amendments to the type certificate, they've allowed their aircraft to migrate from one category to another category within the type certificate, but it can also be done aftermarket as an STC. Sikorsky S58 round piston engine replaced with a twin engine, twin pack, basically bought Sikorsky time while they were developing the S76. S58 featured a Garrett engine replacing a piston engine. A lot of weight saving, increased power. It basically extended the life of these older airframes. Similarly, Hiller 12E, take out the heavy piston engine, put in the turbine, use the reduced empty weight to increase the payload. That's the engine installation for the turbine. More recently, in production, Eagle Copters in Calgary, Alberta, has taken the Bell 407, an in-production aircraft, and replaced it with the Rolls-Royce engine with a 1,000 horsepower Honeywell engine. And most of these aircraft are assigned to helitack operations with the U.S. Forest Service, operating in hot and high altitude and mission environments. Eagle has also taken a twin engine out of the Bell 212 and turned it back into a single engine helicopter using a Honeywell engine. This is currently available, and it in effect turns a Bell 212 into sort of a pseudo Bell 205. The next step, of course, is electrification, and what we see is a number of companies looking at existing aircraft models and replacing the piston or turbine engine with an electric or a hybrid electric or a hydrogen electric propulsion system. Principal advantage is reduced operating costs. If you can reduce the operating costs, you can stimulate the market, be it flight training, charter, regional air mobility. Secondary benefits include reduced emissions and other environment and reduced noise. Good example, 2016, we're now on the 4th iteration of this, United Therapeutics and Tier 1 Engineering with the ER-44. That was the record flight from Thermal to Palm Springs with the battery electric aircraft. Harbor Air and magniX have partnered on the eBeaver program, and this picture shows the installation of the newer engine with 4 inverters. There's a cooling system there, and then, of course, in the fuselage under the floor is the battery pack. This is the aircraft at Oshkosh. Ground running and high-speed taxis 2 years ago, was not able to fly during the show. CAE, this is the aircraft they are in the process of converting to electric in Montreal, working with H55 and with Safran as an engine provider. Diamond Aircraft in Germany is converting the DA40 trainer into an EDA40, designed for the initial phase of flight training where you're doing airport circuits. At Oshkosh this year, Robinson and magniX announced the electrification of the Robinson ER66. Robinson is also working with United Therapeutics, as Mike referenced. What you see there is a powertrain for their fixed wing applications, which includes magniX's new Samson battery pack and their inverters. The helicopter will use the Helistorm engine, which has a higher RPM rating to mate with the transmission of the helicopter, replacing the Rolls-Royce turbine. Battery maker H55 has stretched and are now involved in propulsion and conversions as well. This is the Bristol B-23 that flew around the US this last summer, visiting multiple locations from coast to coast, showing off the aircraft, and it generated a lot of orders for trainers. Aerotech in Moses Lake has done a Cessna Caravan conversion more as a proof of concept than a production program, at least at this point. Ampere is taking the PT6 out of a Cessna Caravan and putting in a hybrid electric engine that uses a red German-built diesel engine coupled with a powertrain. And ZeroAvia has announced plans to retrofit this ex-Alaska Airlines, Horizon Airlines Dash 8-400 with a hydrogen propulsion system. So there's examples throughout history of the retrofits that have taken place and are taking place today. And that's pretty well it for me.
Fantastic.
Yeah.
Yeah, go ahead, Mike.
I was going to say, yeah, that was quite the tour de force there of experiences with STCs and testing. And so I hope that these three presentations have given you folks some insights both into how it works, how you could do it, and then actual experiences. And so we've got about 20 minutes for Q&A. And first, I'd like to, I guess, invite anybody who has experience doing SECs. We've got Ed Lovelace from Ampere to give some of their experiences. And Ed, I know we had talked to you about this in advance. If you could break away between your meetings, I guess would you like to share some of your experiences with Ampere?
Sure. Can you hear me okay?
Yep. You want to turn on?
Okay.
Can you turn on a camera?
Yeah, should be able to do that.
Perfect. You can see your background.
Yeah, that's funny.
Or if not, it's fine. But yeah, would love to have you talk about some of your experiences, both at Ampere and other places you worked.
Yeah, absolutely. I'm just trying to figure out why it decided not to show my face.
Teams seems to be this call seems to be, or this is Zoom, sorry, seems to have some quirks today.
Yeah, okay. Yeah, no problem. But anyhow, in terms of experiences, yeah. So as Ken mentioned, we are doing the STC process for the Cessna Grand Caravan. Generally speaking, I'd say the project has been going as expected. We are doing it, very similar to the way a powertrain upgrade for a GA aircraft would normally be done. There's several companies that have done powertrain upgrades for the Cessna Caravan, so this isn't a new area in those general terms. Obviously, we have some new technology that we're putting in with the integrated parallel hybrid amp drive and a high voltage battery. The other parts of the aircraft STC, of course, are some minor updates to the flight deck, high voltage distribution, some minor updates to the fuel system. And as a consequence of our new hybrid powertrain, it's also going to have a new propeller that's part of the STC kit. The other piece, of course, is the powertrain type certificate. We are the first official hybrid program of record with the FAA for a hybrid powertrain, and that was officially kicked off well over a year ago at this point. And we have gotten through the PSCP stage and the G1 stage, and we're now, deep in the middle of the special condition phase, which is clearly the primary unique piece that everyone has to go through for the electrification technology. We do expect, when that's published in the Federal Register, that there's kind of a couple strategies. We've now seen the FAA converge after 3 or 4 of these all electric special conditions to a pretty standard package of SC requirements. we do expect there'll be some changes with the hybrid powertrain when for the special conditions in that case. Because again, in some failure scenarios, our hybrid powertrain fails back to a reciprocating engine system. So that's a little bit different than the all-electric scenario. So I'll probably pause there in terms of the certification program. In terms of flight test and development, we flew the first proof of concept hybrid Caravan in November of 2023. And we've been working on developing what we call our Gen 2 or commercial intent system. So the way we're defining commercial intent is same configuration as the eventual conforming unit design, but with some of the supply chain elements maybe not frozen and up to the conforming unit standards. And that we expect to be up in the air soon. And that'll inform the final nail down of the system for being able to produce a conforming unit that we can get for credit testing on. And I'll stop there.
Ed, it's Ken. I have a couple questions for you, and I
Sure.
guess you might stop sharing your screen there, or actually you weren't. The first one is, well, I'll say both questions now. First is integrating a initial compression or a diesel engine into an aircraft. It's done before, but mainly on sort of lighter aircraft. And I'm wondering what the specific challenges are relating to that portion of the power plant. And then the second aspect is what's the sort of unique selling point of going with an hybrid aircraft, hybrid propulsion system as you have, given that sort of the P26 is sort of this iconic turbine engine. What's the advantage of what you're doing for, say, an operator?
Yeah, sure. If you think about a Pareto diagram of fuel economy versus empty weight, we're basically moving to something that is a little bit heavier, but has dramatic SFC benefits. So downsized Jet A engine using electricity for the boost power for peak requirements, very similar to hybrid cars in that respect. And for what we get for that is we're putting in a 12-cylinder engine with additional energy offsets from an electric battery that give you 50 to 70% fuel savings. And so if you think about a payload range diagram, because you're carrying less than half the fuel, you actually even have a crossover point in the payload range diagram where you have more payload capability than the original aircraft.
Oh, and how about the other question was integrating a diesel into an aircraft. I've spoken to
Yeah.
some OEMs who tried it on the helicopter front, and they said it's been very challenging. But I'm wondering what your experience is and what the specific challenges are.
Yeah, well, I would say the main challenge that I would highlight is you're losing bleed air. So anything that you used to run off bleed air, you need to either not have that feature anymore in the new product or provide an alternate means to provide it. So, as you think about de-icing, you either need to provide a compressor for inflatable boots, or you need to restrict the configuration to the TKS chemical de-icing system. That's a perfect example. If you want to have air conditioning systems, then you need to provide an electrically driven system for air conditioning.
Thank you.
Great.
But other
Sorry.
than that, we didn't have any other really significant challenges. The fuel system changes, those were pretty routine.
Great. Anybody else would anybody else like to share their experiences with an STC? If not, we can go into Q&A, and I'll just I guess I'll break the ice by asking David a question. So as a flight tester, you're an FAA flight tester. Like, can you share some words of wisdom for designers who are looking to integrate new technologies into existing airframes?
Yeah, thanks for the question, Mike. Yeah, in fact, this might tie into Ed might have some comments on this as well. But from my perspective, with the new technologies, quite often it starts with a prototype and some ideas, and there's some company flight testing, and there's some iterations going on. So when you look at the left to right certification process that's spelled out in 8110.4, it looks quite simple that you go left to right, but there's this iterative loop of running into issues, like I just talked about, losing the bleed air that affects your icing. There's when you do the STC, invariably you're going to touch some other systems, and sometimes when you touch those systems significantly, you kind of have to own them as the STC matures. And so from a flight tester, what's really useful for me is if you're lucky enough to get flight test support early on, what flight test needs to know is it needs to have kind of a holistic picture of all the systems that are affected with your planned STC. But that evolves over time. So sometimes you don't have all those answers. But the more that we can know, the more we can know as a flight tester as to where the modification is going to affect the assumptions we built into the initial certification, the better. And I'm kind of curious, humbly asking, because I know I'm the FAA, I've got the black hat here, but I would humbly ask Ed, what kind of challenges have you run into with flight test?
I mean, I would say nothing that has really been fundamentally a major challenge. I would say probably ask me that question again in about 9 months. Then I probably will be able to tell you a lot more. I mean, as a company, in terms of flying hybrid electric aircraft, we're now 6 years in with 3 different hybrid electric aircraft, closing in, I think, around 35,000 miles flown. But as you say, a lot of that has been with experimental equipment, proof of concepts, and then prototypes of varying fidelities. We've been able to fly, extend our, long distance and time duration flights pretty extensively. But that's, again, not a huge surprise with a hybrid powertrain. Because again, you always have access for crews on the Jet A fueled portion of your system. The next stages of our flight tasting are really going to be hitting all the corner points of the envelope, and for sure we're going to see differences in the way the AmpDrive hybrid powertrain performs against the original gas turbine. We're actually you expect some of those corners to be improvements, and maybe some corners there might be some restrictions on us. But again, a reciprocating engine doesn't have the same kind of altitude lapse that for instance, a gas turbine has. So, some of those will be positives.
So we have a couple questions in the chat, and I want to bring Eve Morier's question to voice it. So this discussion has focused a lot on engines, but STCs can be used to introduce new avionics and autopilots. Can you guys have some other examples, or anybody else want to comment on that? I know Ken had a bit of a list about helicopters in particular, like new interiors. Anybody else have any experience or insights into other things besides engines, interiors, avionics, autopilots?
Prakash, you mentioned you had a comment. If it's as good a time as any to say it.
Okay. Can you hear me?
Yes.
Okay. This is Prakash Patnaik from the National Research Council of Canada in Ottawa. There was a mention of Orinda recip engine, and at some point, which did not work out in Canada, it was sold to an American company. I was involved in that, so just to remind you that there is a member here who worked on that extensively on the certification side. On the STC side, when I was working for Magellan Aerospace, I have worked on PD6 engines, very complex component of PD6 turbine, successfully obtained the STC in Canada, recognized by the FAA. It was a material science problem, fatigue problem, surface engineering problem, very complex. But we did that in 3 years. The FAA was recognized that in about 1 year. They asked us to do some additional tests. Another STC we got on titanium components for fitting fatigue, very complex problem in titanium alloys on the engine side, big aircraft engine side. So those are the STC that I have worked with from a technology viewpoint. When I moved to government, I was out of the STC business because there was a conflict. Transport Canada saw a government employee working with STC. So we remained as consultant. We have extensive aerospace labs that we do conduct the testing. So we do everything for the STC and submit it to Transport Canada, FAA. They come here, witness testing and so forth, to give the final certification. Last comment. We have two projects, one on electrification and hydrogen that is going on right now, but that's for the Royal Canadian Air Force. We're looking at net zero by 2050. So looking at electrification, both 100% and also hybrid. We've identified a platform and a project that is quite well known. H2 can fly. It's basis of hydrogen and electrification. So these are the two projects that are ongoing that I'm not the project manager, but I'm an advisor to them. So I just wanted to let you know that Canada is active as well.
Yeah, absolutely, for sure. So we have about 5 minutes left, and there's maybe a couple questions. There's one question in the chat I wanted to answer, and then I'll ask. Then we'll go to ask Andy to close out the meeting. But Ken, go ahead.
Yeah, Dave, I guess the question for you is, we sort of talked about STCs of propulsion or avionics or other upgrades to existing aircraft, but do you feel that there's going to be a cycle of STCs applied to new advanced air mobility aircraft down the road? And will it be any different? For example, I've often felt that some of these aircraft will require emergency flotation, even though they're multi-rotor. Applying an STC to an eVTOL, is that going to be any different than what's happened in the past?
I think the process stays the same, but you would be applying an STC to a special class certification. So it can certainly be done, but until we have the first of multi-copter advanced air mobility type certificate, I don't think we can go to the STC yet. But
Hey,
Al's got something.
yeah, I can jump in and add to what Dave was just saying. I'm Al Lawless with the eVTOL Flight Test Council. One of the things we've been talking about in the council is if you want to do an STC, how much more involved would it be than a traditional airplane, just swapping an engine? And it can be quite a bit bigger for VTOL aircraft because the heat sinking is a huge problem. And if you add bigger batteries, you get more battery density. Maybe the duty cycle isn't valid for that, and so forth and so on. So it's the same process as Dave said, but there's more complications, a little bit more involved than a straightforward aircraft. And so that's where the gotchas can be. Over.
All right, I'm going to just briefly. So George Bryan brought up the question about SAF, and I'll answer that briefly. But anybody else is also willing to invited to amplify it. So new fuels, and this is also most piston engines, at least in the U.S., use leaded gas, and there's different low unleaded gas alternatives that are being looked at, and the same thing with SAF, where generally they test the new fuel with the engines. So SAF generally for turbines, and unleaded for pistons, and then they approve. At least with SAF, they approved a certain number of engines to run with 30% SAF, and I believe that was an STC on the engines. And then as more and more experience was gained, it was, I think, generally allowed that this SAF was allowed to be used for all turbine engines. So I don't know if anybody else has anything more they wanted to add, because I know we're out of time. But that's my understanding.
I would just add that I think there's potential for a future webinar on SAF and hydrogen and batteries, just like what's the difference between them all. Because hydrogen is not a sustainable aviation fuel, which makes no sense, especially to people that are not in aviation.
Right. Yeah. The FAA and others classify SAF, sustainable aviation fuel, as being a synthetic fuel or a biofuel for Jet A.
SAF is something I'm working on, and I have a speaker in mind, and so I would like to do that too. I think that would help. It's something I don't fully understand, and I think a lot of us can use some more clarification about how it works, what are the upsides, what are the downsides, and how does it compare with things like conversion to hydrogen. I think we're out of time. Any other final comments? Wonderful meeting today. I thought this was a home run. I'm really glad we're able to team up with HYSKY Society. Thank you, Danielle. And specifically, thank you, speakers. Thanks, Mike, for moderating. I hope we could do more of these. Danielle, we have time for a quick plug. You have an event coming up, don't you?
We do. Flying High, November 5th. Be there. Just go to our website, hysky.org, HYSKY.org. Tickets are practically free, $30. So join us there. We've got a great lineup. Thanks, Andy.
I think it's a great value. I just signed up, and everyone check your chat notes. You'll have that website there, or just look up HYSKY, and hope to see you at that event and at our future meetings. Thank you, everyone, for being here. Awesome meeting today, and thanks, participants, speakers. We really appreciate your time and energy.
Bye. Thanks, everyone. Thanks, Mike, for moderating.
Thanks. Great session.
Thanks, Danielle.
Take care.